We saw a little bit about how to do subnetting on the classful boundary, on the dot boundary. What about classful subnetting or classless subnetting? What if we need to subnet on not on a class boundary for whatever reason? What if we needed to borrow a few bits? What would that look like? So if we were to do classless subnetting, and I'm not sure if that's of the best term for it or not, but not network. What if we were to not subnet on the dot boundary? So in this case, we'll say not on a dot boundary. So again, what we did before was we did 192.168.1.100, and we use a mask of 255, 255, 255.0. So that put us on the 192.168.1.0 subnet. Well, if this is what we were given, 192.168.1, but we realized that we had a router and we needed to use an address space on both sides. Whenever we have a router, we have two different networks, network 1, network 2. I need to split this into at least two networks. But I don't have a number 2 here. Whoever gave this to me only gave me the 1. So what am I going to do? How am I going to make this work? Well, I'm going to have to take some of my bits that were over here that were host bits, and again, anytime we have a 0 in the subnet mask, it's my host portion, and I'm going to have to use one of those maybe two of these to create a bigger network boundary. So again, the 1 here needs to be my network portion. Well, what does that look like overall? How does that get set up? Well, so we need to look at the whole using different numbers of 0s and 1s as far as creating more networks and or more hosts, or less hosts and more networks. And it's always going to be a, that's all right, it's going to be a different type of structure. So we need to look at what the overall boundary structure looks like. So if I were to say I had 255, that's 1, 1, 1, 1, 1, 1, 1, 1, right? So that's 255 in binary. Now, when we looked at our mask before, 255.255.255.0, we were looking at this whole structure here. And notice these are all 1s. And I'm not counting them out until I get to the first 0, and then it's all 0s the rest of the way. That's not some random thing. There's a rule that says you have to be 1s contiguous from left to right, and once you get to the first 0s, it has to be 0s the rest of the way. So if I were going to have 1, 0 in my subnet mask, and we'll get to the whole purpose behind this shortly. If I'm going to have 1, 0, where does it have to be? It has to be right there. And then all the rest of these have to be 1s. What if I needed 2 0s? Why would I need 2 0s in my subnet mask? Well, because it's the number of hosts. Again, this is going to be dictated by the number of hosts that we mean. And I'll show you in a second. If I needed 2 0s, they're going to have to be right there. And then I'm going to have 6 1s after that. What if I need 3 0s? 1, 2, 3 0s. Sure enough, and again, without stopping to discuss this any further, you can see how that pattern is working. And then if I have 4 0s, 2, 3, 4, 5 0s, 1, 2, 3, that's what 5 looks like. And then 6 0s, and then 7 0s, and then finally if all 8 of these are 0s. This is the combination, this is the bit pattern that you can have for a subnet mask. You can't have anything else, because in a subnet mask you can't have a combination. That cannot be a subnet mask because it's not contiguous 1s and 0s. If I've got a 1 and a 0 here, it has to be 0s the rest of the way. If I've got 3 1s and then a 0, it has to be 0s the rest of the way. So following those rules, then the only combinations for subnet masks that you have from 8 1s, which is at the top here, from 8 1s all the way down to 8 0s, those are the numbers. So what are these? How do we do binary to decimal conversions? How do we figure out what the decimal values are? We know a couple of these because they're pretty easy. We know that 0 is all 0s, and we know that all 1s is 255. How do we know that? Well, because we talked about it before. But maybe we should actually look at that whole conversion process of converting decimal to binary or binary to decimal. In order to do that, I really need to see what the values of the placeholders are. this 1 right here, what value is it? What is this value of a 1 in decimal? All right, it turns out we can express that in terms of decimal as 128 dot, or not dot, 128, 64, 32, 16, 8, 4, 2, and 1. So if I were to put 11000001 in here, and I want to convert it to decimal, I simply bring down the decimal value with its over a 1. So this is 128 plus 64 plus, well, do I just negate these? No, realistically, this is 1 times 128 plus 1 times 64 plus 0 times 32. Well, that's 0. Plus 0 times 16. Plus 0 times 8. Plus 0 times 4. Plus 0 times 2. Plus 1 times 1. Do I really need to add all the zeros? Do I need to put that in here? Or can I just say, look, why don't I just add up the values where the 1s are? Because there's no reason to add the zeros. Ah, that makes sense. So in that case, 10000001 is 128 plus 64, which is 192, plus 1 is 193. So this is 193. And that's the whole decimal to binary conversion. Wherever the 1s are, you just add up the values for the 1s. Oh, so now if I look at my subnet mask and I want to know what the values are, what dotted decimal value would I use for my subnet mask, I can simply go, well, what is, whoops, let me erase the other ones that are up here. What is 10000000? And that would be the second line item right here. Well, that would be 128, well, 128. So that's 128. What's the next line? What's this one? Well, I add one more 1. And so now it's 128 plus 64. That's 192. Well, what's the next one? Well, that would be 3 1s. So my 3 1s is going to be 192 plus 32, 224. Oh, cool. Well, what's 4 1s? Well, I already have 224. Let me add 16 to that. 240. Yeah, well, what's the next one? Oh, well, that would be 5 1s. So let me get rid of this 0. So I have 240 here right now. 240 plus 8, 248. 248, add one more 1 to that. So 248 plus 4, 252. 252 plus 1. I'm sorry, 252 plus 2. 254, and did it actually work if we did it right? If I take my 254 and I add 1 to it, it should be, dun dun dun, 255. These values right here, 255, 254, 252, 248, 240, 224, 192, 128, those are the only possible combinations that you can have for this classful or not zero boundary. Well, I guess if I want to go that route and actually say it, then those numbers aren't going to include 255 and 0. They're just going to be these numbers 254 through 128. These right here, these ones in blue, are what I call the funky octet values. So your subnet mask can look like 255.255.255.240, and that's perfectly fine. And this 240 is what I call the funky value. So what's 240 in binary? 11110000. That means whatever number is out here in your IP subnet in your IP address. So 200.200.5.100. So out of this 100, a piece of this 100, the left 4 bits of 100 are the subnet. The right 4 bits of 100 are host, network, host. Which is why sometimes people don't really like this complex subnet masking or subnetting on the non-dot boundary. Because now I have to take a number that I know, 100, and I have to think about, well, 100, part of it is subnet, part of it is, how do you know? Well, that becomes problematic. Again, what we're going to ultimately do is look at block size values, and the block size values will help us figure out exactly what those numbers are when we get there. And we'll save block size for another discussion. Coming up here shortly, I will give you one more thing about block size so that when I do it later on, it'll It'll kind of get reinforced for you. I'm going to tell you that 256 minus funky is block size. Remember that. All right, I suppose I can do that one example because it's sitting right here on the board. If I have 240, which is funky, right? We said that the funky value was the one that wasn't 0 or 255. So 256 minus funky. I probably shouldn't use the word in here because I actually want to use a mathematical value. Actually, subtracting funky is difficult. But if funky is 240, that makes my block size 16. And we'll do that coming up.